In this video, we are going to talk about how to convert molecules from Newman's projections to Fischer projections, and also how to convert from Fischer projections to perspective. Let's convert this Newman's conformer to a Fischer projection. So all you do is that you need, this is a staggered conformer. So to convert it to a Fischer projection, you need to draw the eclipse form of this conformer by rotating the carbon at the back by 180 degrees. So rotate the carbon at the back by 180 degrees. So let's do that to this carbon. So let's draw the carbon in front. So this is the carbon in front. This place is a thiol, SH, and then there is a chlorine here, and then the top here is a CH3. And then let's draw the carbon at the back, but we need to rotate 180 degrees. So if we rotate 180 degrees, this chlorine will be at, this CH3 will be at where the chlorine is, and then this CN will be at where the thiol is, and then this CH3 will be at where this CH3 is. And this means that this CH3 is going here, and then the cyno group is going to where the thiol is. So there is a CN here, and then this CH3 is where will be at where the Cl is. So this CH3 will be here. So let's go ahead and draw the Fischer projection. You see that this carbon is eclipsing this one. So if we draw the Fischer projection, the carbon in front is this carbon, and the carbon at the back is this carbon. Now, all the groups that appears to the right will remain at the right, and all the groups that appears to the left will remain at the left. You can see that this CH3 and this CH3 are in the plane of the molecule, and therefore they are those on the vertical axis. So this CH3 is also here. And then chlorine is on the carbon in front, so this place is a chlorine. And then this CH3 is on the carbon at the back, and the CH3 is over here. This thiol group is on the carbon in front, so the SH is over here. And then the cyno group is on the carbon at the back, so the cyno group is also over here. So we've converted this molecule to the Fischer form. Let's do same to this molecule. You can pause the video at this point and then try. So as we said earlier on, you need to first rotate the carbon at the back by 180 degrees to form the eclipse form of this molecule. So let's go ahead and rotate the carbon at the back by 180 degrees. So let's draw the carbon in front. This is the carbon in front. And then this side is a CH3. And then this is a bromine group. And this side is also a CH3. And let's draw the carbon at the back. But then we'll rotate it into the eclipse form by rotating it by 180 degrees. And if we do that, this side will be a fluorine. This fluorine will come to this side. This CH3 will go to this side. So this side will also be CH3. And then the thiol will go on top. And then the SH comes to this. And so we can go ahead and draw the Fischer projection. So you see that this CH3 is eclipsing this SH. So the carbon in front is bearing a CH3. That is eclipsing a thiol group on the carbon at the back. So this is the carbon at the back. So the thiol is here. And then the group at the right hand side, the bromine is on the carbon in front. And then the fluorine is on the carbon at the back. And there is a CH3 here, which It's on the carbon in front, and there's another CH3 which is on the carbon at the back. So you see that we have been able to convert this molecule to its Fischer form. Let's also talk about how do we convert a molecule from a Fischer projection to a perspective drawing. Now let's consider this molecule. Let's convert this molecule from the Fischer to the perspective. We've already established that the groups that are on the vertical line are the groups pointing away from us. So this is the carbon. And then this is the group pointing away. COOH is pointing away. And then CH3 is also pointing away from us. And then the group that are pointing towards us, this proton is pointing towards us. And also the imine group here, NH2, is also pointing towards us. Now, let's try and draw this molecule in its perspective. However, let's determine the configuration of the molecule. If you convert a molecule into another form, the R or S configuration must remain the same. It must not change. So this place, nitrogen is 1, then carbon is 2, then CH3 is 3. It's going in this direction. However, the proton is pointing towards us, and therefore we must negate the configuration. So instead of an R, this is an S configuration. So we need to draw the S configuration of this molecule in perspective. So let's try. Let's put the COOH in the plane of the molecule. A COOH and then the NH2 in the plane of the molecule. So this is a COOH and then an NH2 in the plane of the molecule. And then this CH3 is on a dash bond. So here's a CH3 and then the proton is on a wedge bond. So this proton is on a wedge bond. Now let's determine the configuration in this case. So this is 1, this is 2, and this is 3. It is going in the clockwise direction. However, the proton is pointing towards us, and therefore we must negate the configuration, and therefore this is an S. And so this is the proper perspective drawing of this molecule. Let's come to this. You can pause the video at this point and try. So as usual, the groups on the vertical line are those pointing away. So we'll put them on the dash bond. Here's the CHO, and then this side is also a CH2OH, and then this group is pointing towards us. So the OH is here, and then this one too is also pointing towards us. The proton is also here. So let's go ahead and then draw the perspective form of the molecule. So this is the carbon, and then we want to put this CHO and OH in the plane of the molecule. So this is CHO, and then the OH is in the plane of the molecule. And then you can see that there is this CH2OH that is pointing away from us. So CH2OH is pointing away from us. And then the proton is on the wedge bond, which is pointing towards us. So the proton is here. Now let's determine the configuration of this molecule. This is 1, and then we have this as 2, and then this is 3. So it is going 1, 2, 3. It is going the anti-clockwise direction, but the proton is pointing towards us, and therefore this is an R configuration. Let's determine the configuration here. This is 1, this is 2, and then this is 3. So it is going the anti-clockwise direction, but the proton is pointing towards us. So this is also an R configuration. Now let's come to this molecule. So let's determine the configuration over here. This place is 1, and here is 2, and then this is 3. So anti-clockwise direction, but the proton is pointing towards us, and therefore this is an R configuration. And then here is 1, and this is 2, and then this is 3. The proton, so it is an R configuration, but the proton is pointing towards us, and therefore this is an S configuration. So let's draw this molecule in perspective. We are standing at this point. If we stand at this point and we look up, you will see that our right eye, so this is this carbon here, and then it is bonded to this carbon over here. And if we stand at this point and we look up, you will see that our right eye will be looking at the chlorine and the bromine, and then our left eye will be looking at these protons over here. Now, the chlorine and then the bromine are the molecules or are the atoms that are pointing towards us. And therefore, let's represent them with the wedge bond. So there's a chlorine group here, and then there's also a bromine group over here. So a chlorine and a bromine. And then there are 2 protons that are pointing away. So there is this proton here, and there is also this proton here. And you see that this is a CH3. It is in the plane of the molecule. And this is also a CH2OH. Now let's determine the configuration here. This is 1, and then this is 2, and this is 3. The proton is pointing away from us, so this is an R. And then if we come here, the bromine is 1, and then this side is 2, and then this is 3. So anti-clockwise direction, it is the proton is pointing away from us, so this is an S, and that is exactly what we have here, an R and an S. So this is the perspective drawing of this molecule.